Hello and welcome to the channel. In this video, I'd like to show you how to securely connect two private networks in separate locations over the internet so that hosts from one private network can freely talk to hosts in another private network, all through a secure VPN tunnel. Such a concept is called a Site-to-Site VPN. It's often used to connect branch offices to a central office. In this model, you don't have to install any additional software on the client machine, as all the configuration is done on the routers. Now the fun part, as the routers will use MikroTik devices. Moreover, we'll tunnel the traffic through Cloudflare infrastructure. As a bonus, I will show you how to use Cloudflare to securely access your MikroTik routers, as well as how to create a Road Warrior VPN. My name is Filip. Let's get started. What does it mean that we'll use Cloudflare infrastructure? Basically, each router will connect back to the nearest Cloudflare POP. POP stands for Points of Presence. It's a data center location where Cloudflare has servers deployed to provide its services. As of today, Cloudflare has over 300 POPs in over 100 countries. But why would we want to do that? Why not interconnect the routers directly? Going through Cloudflare has certain advantages. First of all, Cloudflare uses its own private high-speed backbone network to route traffic between POPs. This greatly reduces the latency and packet loss compared to the public internet. It's especially visible when sites are in different countries or continents. Second of all, you don't need a static public IP on your routers. As the connection from the router to Cloudflare Edge is outgoing, it's always the client that initiates the connection. No port forwarding or opening your firewall for incoming traffic is needed. There are also other benefits like traffic inspection, firewall, identity-based access policies and more, but we'll focus only on those two: speed and benefit of not having a public IP. Of course, there are also some downsides. When you have two sites that are geographically close to each other, where the latency between those sites is low, adding Cloudflare in the middle would make it worse. Another downside is that you don't have the full control over the routing of your traffic, as it flows through a third-party infrastructure. Lastly, unlike Cloudflare's commercial products like Magic One or Magic Transit, the free Zero Trust service does not offer establishing BGP session between your Edge routers and Cloudflare POPs and announcing IP prefixes to Cloudflare via BGP. But for network deployments where topology does not change often, Zero Trust network access with static routing is sufficient. Let's start with a few prerequisites. First, you need to register with Cloudflare Zero Trust. I've linked a detailed video in the description to guide you through the process. Once that's done, let's head over to Cloudflare dashboard and navigate to Zero Trust, Settings, Network, and ensure that the proxy option is enabled. This setting forwards your traffic to Cloudflare Gateway for policy enforcement. Double-check the proxy is enabled for TCP, UDP, and ICMP protocols. Next, you'll want to enable Allow Warp-to-Warp connection. This makes sure that devices using Warp can communicate with each other. Let's switch over to Warp client. Make sure that Override Local Interface IP is turned on. By default, every device gets the same 172.16.02 IP address, but enabling this option assigns a unique address from the 100.96/12 range to each device. Now let's click the three dots next to your profile and choose Configure. Let's head to Split Tunnel Settings. Here you decide which traffic should go through the tunnel and which should be excluded. My policy is set to exclude, so all ranges listed here bypass the tunnel. Let's click Manage to edit the list. By default, the full 100.64/10 range is excluded from Cloudflare routing. To make sure that 100.96/12 is included, let's remove the 100.64/10 entry and then add back two smaller ranges, 100.64/11 and 100.112/12. Done. The configuration is now ready. All prerequisites are set, and we can move on to provisioning the tunnels. Since Cloudflare uses WireGuard as its VPN technology, if we know the tunnel details, we can establish a secure connection from our MikroTik routers to the Cloudflare Edge. To generate these details, we'll use a Linux server to register the tunnel and retrieve the necessary parameters. For this purpose, I have an Ubuntu server ready to go. The first step is to install the Cloudflare Warp client on the Ubuntu server. Let me import the Cloudflare GPG key, then let's add the Cloudflare Warp repository. Next, let's update the packages list and install Warp software. Now let's set up the first tunnel. In the Cloudflare console, I will go to Tunnels and click Add a tunnel. I will choose the Warp connector for the tunnel type and click Next. I will name the tunnel Site1 and click Create Tunnel. Next, I will copy the authentication token. That's the one starting with EY. Then I will click Next. At this point, the tunnel is created but still inactive. Back on the Ubuntu server, I will initialize a new tunnel with Warp CLI connector new and paste the token we obtained earlier. Let's accept the policy, and the tunnel is set. We are not starting the tunnel on this server as we want to launch it on the MikroTik router. Let's go to MikroTik. I will create a new WireGuard interface. Let me set the MTU to 1420, name the interface Warp, now the private key. To get it, I will go to Ubuntu and extract it from the registration file. Let's now copy the key and paste it into the MikroTik CLI. Let's list our WireGuard interfaces to confirm it's there. All good. Now we need to set up a WireGuard peer. To do that, we need a few parameters. Let's go to Ubuntu server and extract the target endpoint we'll be connecting to. Let's also extract peer's public key. Now let me go to router and add the WireGuard peer. I will go back to Ubuntu VM and copy the peer IP. Let me now paste it in the router. Let's set the endpoint port. I will also copy it from Ubuntu and paste it here. As the interface, we'll put our newly created Warp interface. Let's name the peer CF. Let's also set persistent keep alive to 30 seconds. That will make sure the tunnel is up even if not used. Let's configure the allowed addresses to any. We want to ensure the tunnel accepts traffic between any addresses, regardless of their source or destination. To get the public key of the peer, I will go to Ubuntu and copy it from there. I will then paste it here. Let's confirm the peer. Okay, it's there. Finally, let's see what is the tunnel IP for our interface. I will go to Ubuntu machine and extract it from the configuration. Okay, 100.96.0.26 is the IP our MikroTik router will have within the Cloudflare network. Let me set this IP on our WireGuard interface. Mind that I did set the mask to /12. That's what Cloudflare is using. Just to confirm, I will display interface IPs. Okay, all looks good. Just to sum up, to connect our MikroTik router to Cloudflare Edge, we've used WireGuard Tunnel. We first set up a Cloudflare Warp tunnel using a Ubuntu server to retrieve the required tunnel parameters, such as keys, endpoints, and addresses. After extracting these details, we configured a WireGuard interface and peer on the MikroTik, ensuring secure connectivity through the tunnel. This method would work for any device that supports WireGuard. When we go to Cloudflare console, we see a new tunnel up. The tunnel between our MikroTik router and the Cloudflare Edge. Let's create a tunnel between Cloudflare and the second router. I will click Create Tunnel, select Warp Connector, click Next. Let's name the tunnel Site2 and click Create Tunnel. Now let's copy the authentication token and click Next. Okay, our second tunnel has been created, but it's not yet active. Next step is to configure the MikroTik router in another location to use the tunnel. We'll simply repeat the same steps as we did for the previous router. Let's go to our temporary Ubuntu server. As this server is already registered with the tunnel, we need to first clear its configuration. To do that, I will stop the Warp service. Then I will go to the folder where Warp stores its tunnel configuration and just remove all configuration files. Now I will start the Warp service again. With blank configuration, let's initialize a new Cloudflare tunnel connection. Like before, instead of starting the tunnel on this Ubuntu server, we'll only extract its WireGuard parameters. First, let's get the WireGuard interface secret key. Then I will go to second MikroTik router and create a new WireGuard interface. I will set the MTU to 1420 and name it Warp. Now for the private key, let's copy the value extracted in Ubuntu and paste it here. A new WireGuard interface has been created. Now let's go back to Ubuntu and extract the WireGuard peer IP and port, as well as the WireGuard public key. Let's now go to our second MikroTik router and let's add the WireGuard peer. For the endpoint IP, we'll put the IP of the Cloudflare Edge. I will copy it from Ubuntu and paste it here. Now let's provide the endpoint port. Again, I will copy it from Ubuntu and paste it in our command. The interface will be warp that we've just created. Let's name the peer CF. I will set the keep alive to 30 seconds so the tunnel won't go down. Let's set the allowed addresses to any IP. Finally, let me copy the public key of the peer from Ubuntu and paste it here. Okay, our peer has been configured. Let's check the configuration. All looks good. Lastly, let's go to the Ubuntu server and extract the IP of our WireGuard interface. Now on the router, I will assign that address to warp interface. Mind the /12 mask. Okay, all is set. Our MikroTik router at the second location is connected to Cloudflare infrastructure and has the IP address 100.96.0.27. Similarly, the MikroTik router at the first location is connected to the Cloudflare Edge with the IP address 100.96.0.26. Let's check reachability between the routers over Cloudflare backbone. I will ping router 2 from router 1 via the 100.96 IP. Works. If I trace the route, we'll see it's going via Cloudflare backbone. In the Cloudflare console, we see both tunnels up. Mind that, we no longer need the Cloudflare warp service on Ubuntu, so I will just remove it. In fact, we don't need the Ubuntu server at all. It was used to register tunnels with Cloudflare. Just to sum up, after setting up the first site, we repeated the process to register and configure a second MikroTik router with its own Cloudflare warp tunnel, extracting and applying new WireGuard parameters from the Ubuntu server. Both routers are now successfully connected to Cloudflare Edge with unique internal IPs, enabling direct communication over the Cloudflare backbone, and the temporary Ubuntu server is no longer needed. Let's see where we are. We have two MikroTik routers in separate locations. Router 1 in Site 1 and Router 2 in Site 2. Each router has its own internet connection, but also each router has a WireGuard tunnel to the closest Cloudflare POP. Moreover, routers can talk to each other through the Cloudflare backbone. Let's proceed. Behind router 1, we have 10.1/24 private network. Within that network, we have a client machine. If we look at its routing table, we'll see that router 1 is its default gateway. It means that if Alpine 1 wants to contact a host that's not on the local network, it will send the traffic to the default gateway. That's our MikroTik router. There's an identical setup on the other side. We have a 10.2/24 private network behind router 2. Within that network, we have a client machine with a default gateway set to the router. Our goal is to have reachability between client machines. To do that, I will go to router 1 and add a static route. I will tell router 1 that in order to get to network behind router 2, it needs to send the traffic to router 2 tunnel IP. Now, let's do the same on the router 2. I will add a static route that says, in order to get to the network behind router 1, you need to send traffic to router 1 tunnel IP. Let's see if that works. I will go to the client machine sitting behind router 1 and try ping the client machine sitting behind router 2. Does not work. Let's check the routing. All looks good. Traffic to the other client should be routed via default gateway. That's our router 1. Router 1 knows to route the traffic to network via router 2. So, why does this not work? If we run the trace from client 1, we'll see the traffic get stuck within the Cloudflare backbone. That's to be expected. Cloudflare does not know anything about our 10.1/24 and 10.2/24 networks. Let's fix that. I will go to Network, Routers, and click Add a Route. We'll tell Cloudflare that 10.1/24 network is behind Site 1 tunnel. Let's also add another route and say that 10.2/24 is behind Site 2 tunnel. Let's test the connection now. Works. We successfully established a full routing setup between two separate sites, each with its own MikroTik router running WireGuard tunnel to Cloudflare. By configuring static routes on both routers and informing Cloudflare about the internal networks, traffic can now flow seamlessly between clients in both sites. This setup not only enables site-to-site connectivity, but also ensures resilience and optimal routing through the Cloudflare backbone. Now that we've built the core site-to-site connectivity, let's explore what else we can do with this setup. Connecting routers directly to Cloudflare opens up two additional use cases. First, you can use the 100.96 addresses to remotely manage your routers. Let me show you how. I have a client machine with Cloudflare Warp software installed. Let's register it with Cloudflare Zero Trust. I will click Next and accept the privacy policy. Next, I will go to Settings, Preferences, Account, and click Login to Cloudflare Zero Trust. We are prompted for the team name, the one created during Zero Trust registration. You can find it in the Cloudflare console under Settings, Custom Pages. I will copy the team name and paste it in. After clicking Next and accepting the privacy policy again, we need to authenticate to join the Zero Trust team. I will use a one-time code. Let me enter my email. Then I will retrieve the code from my inbox, paste it here and click Sign in. Success! Our device is now registered with our Zero Trust domain. Let's connect to Zero Trust and check the VPN tunnel IP we were assigned with the Cloudflare network. Perfect. We've been assigned an IP in the 100.96/12 range, specifically .25. This means we are now in the same network as our MikroTik routers. Let's try pinging router 1. It works. Now, let's try logging into the router via Winbox. Success! We are in. See how simple that was? By registering your client machine with Cloudflare Zero Trust and connecting it to the Cloudflare network, you can securely access your MikroTik routers using their Cloudflare-assigned IPs. This method provides a straightforward and secure way to manage MikroTik routers, eliminating the need for complex VPN setups. Lastly, we can use this model to configure a Road Warrior VPN. A Road Warrior VPN is a specific type of VPN configuration designed to allow remote users, the Road Warriors, to securely access a private network from anywhere on the internet. As we are connected to the Cloudflare Zero Trust and the routers know how to get to private networks, let's try to reach out to Alpine 1 VM sitting behind router 1. Unfortunately, it does not work. The reason for that is the split tunnel configuration. Let's go to Settings, Warp Client, edit the default profile, go to Split Tunnels. We'll see a list of all the networks that are not routed through Cloudflare. The 10/8 network is not routed via the tunnel. Let me remove it from the list. From now on, the 10/8 network will be routed via Cloudflare. Let's test the connection now. Works. Let me try to SSH into the server. We are in. With this setup, I can securely access my private networks on the go. One important thing to keep in mind, the split tunnel configuration applies only to client devices with the Cloudflare Warp software installed. The Warp client automatically updates the device's routing table. For example, if I go to Preferences, then navigate to Advanced, Split Tunnel, I can see which networks are excluded from being routed through the tunnel. However, split tunnel configuration does not apply to MikroTik routers. On MikroTik, we control which networks use the tunnel by modifying the router's routing table. And that's it. We've successfully connected two private networks in separate locations over a secure VPN tunnel using MikroTik routers and Cloudflare's backbone. As you've seen, this setup not only connects your site securely, but also lets you manage routers remotely and access private networks on the go. If you found this video helpful, please leave a like and let me know your thoughts or questions in the comments below. Don't forget to subscribe for more in-depth networking tutorials. There's a lot more to come. Check out the video description for useful links, including a deep dive into Cloudflare Zero Trust setup and related resources. Thanks for watching, I'm Philip, and I'll see you in the next one. Happy networking!